What if I told you the universe might be written in a language so perfect that one single equation could describe everything that has ever existed, from the birth of stars to the thoughts firing inside your mind? Yet somehow, we still can't read the code. For more than 100 years, physicists have been split between two beautiful but incompatible visions of reality. Einstein gave us general relativity, a smooth, majestic universe where gravity shapes the cosmic stage. Quantum mechanics gave us a chaotic universe, a jittering sea of probabilities at the smallest scales. But here's the conflict. Both theories work, but they refuse to work together. Black holes, the Big Bang, the center of a neutron star, these places demand a unified explanation. And finding that explanation has become the greatest scientific quest of our time. Let's break this down in the simplest possible way. Gravity, the warping of space-time, controls the massive, cosmic world. Quantum physics, the dance of subatomic particles, controls the tiny, microscopic world. Both rule their domains flawlessly. But when we zoom into a black hole, where matter becomes infinitely dense, the equations explode. They literally produce nonsensical infinities. And here's where things get strange. One idea suggests that everything, electrons, quarks, even gravity, is made of tiny vibrating strings. Different vibrations produce different particles, like musical notes from the same violin string. But string theory demands extra dimensions. Not just 3 of space, but maybe 10 or 11. Another idea proposes that space-time itself is made of discrete, tiny atoms of volume, like pixels in a cosmic simulation. Both theories are elegant. Both could be wrong. Neither has been experimentally proven. Physicist Sabine Hossenfelder once said, "We're running out of experiments that can tell us whether we're right." Because probing the Planck scale, the level where quantum gravity lives, requires energies beyond any machine humanity could ever build. So the question becomes, is the theory of everything unreachable? Or are we asking the wrong question? But this isn't just physics. It's personal. Every human being carries the same question somewhere inside them. Why are we here? How does all of this fit together? A theory of everything is not merely an equation. It's our attempt to stitch meaning into the chaos. When you look at your hand, the atoms that form it obey quantum rules. When you drop that hand to your side, your motion obeys relativity. You are, quite literally, a bridge between two incompatible realities. And maybe that's why we care so much. Because understanding the universe is a way of understanding ourselves. Here's the twist no one expects. What if a theory of everything isn't one equation at all, but a network of truths? What if the universe isn't simple, but elegantly layered? What if gravity, quantum mechanics, consciousness, and complexity aren't waiting to be unified, but understood as different levels of the same cosmic architecture? Some physicists believe the real breakthrough won't be mathematical. It'll be conceptual. A shift in how we think about space, time, and even information itself. And that's the moment where everything clicks. The universe might already be unified. It's our perspective that's fragmented. Maybe the theory of everything won't tell us why the universe exists, but it will show us how the universe holds together. And the closer we get, the more we realize something profound. The universe is not obligated to make sense. But we humans are driven to make sense of it anyway. And that relentless curiosity is part of the very story we are trying to decode. Until we discover the theory of everything, we remain explorers wandering through equations, searching for the one that finally explains us. Please subscribe to Scientific Valley for more interesting videos.